Alright, so today's weekly contest, number of bit changes, the first problem, number of bit changes to make two integers equal. Alright, so we are given 13, n is equal to 13, k is another integer, and we basically need to, the question asks us to look at the problem from the binary representation perspective, 1, 1, 0, 1. This is 13, 0, 1, 0, 0. This is 4. So we are allowed to use n and change all the ones to zeros if required, so that by the end we get the value k. So there will be scenarios where this is not possible, when the set bit of k is a 0 bit in n. In that case, this can't be, because we can't change 0 to 1s, we can only change 1s to zeros. So in that case, this is not possible. And let's get into the code. Since there are 32 bits in the integer, as per the constraint, I will traverse those 32 bits. I will check. I'll have a count. It will be 0 initially. If or I'll take the bit out, bit n, which is equal to 1 and n I. This will give me bits right from the LSB, LSB till MSB one by one. And similarly, I'll get the bit k. I call this bit k, and this will be the same thing but with k. If bit n is equal to k, sorry, is equal to 0, and bit k is equal to 1, in that case I'll return -1, since it's not possible. Otherwise, I'll check if bit n is equal to 1 and bit k is equal to 0. In that case, I can convert, and I have to increase the count, so I'll increase it by 1. And now I'll return. Let's see if this works. This is of one operation, if I'm not wrong. Right, since we have only 32 bits, this is O of one operation, I believe, and that's the code O of one space as well. The second problem, vowels game in a string. So again, we have a string S. We have Alice, whose turn, in her turn, she will take a non-empty substring from S such that the substring contains odd number of vowels. And for Bob, take substring S, which is even number of vowels. Both play optimally. So this is an important point to note, because if the vowel is even, all right, and Alice has her first turn, right? So in that case, she will always take her odd vowels, and the left will be odd. So in that case, Bob will lose. And in the other case, when the vowel is odd itself, then Alice will take all of the string instead of taking the substring, and again Bob will lose. So Bob will lose either way. Bob will only win in case where we have zero vowels, right? So it's just a trick question. I will have a count. I will check for the vowels. If C is equal to A, or let me copy this, U, U, E, I, O, U. So I will just increase my count. If count is equal to 0, so I have to return false if Alice loses. So if count is equal to 0, only then that case Bob wins and Alice loses, so this will be false. Otherwise, in all scenarios, I'll return true. So O of n time complexity, O of 1 space complexity, and yeah. So maximum number of operations to move ones to the end. This is a very interesting problem, very straightforward. So we are given something of this sort of a string, which is binary string, and we are asked to take ones, take a character which is a 1, and the one after that should be a 0. So this should always be 1 0 when I select a 1. Okay, and I change this 1, I take it to some other one or till the end. If there are no ones in the middle, then I take it till the end. So here I have a 1 in the middle, so I take this one and combine it with this streak. So this will be a streak, right? 1 1 1. Similarly, now I can see that there is another, when there is a streak in between and a zero, in that case, I can do the same operation for all the number of ones in that streak. That will contribute to three operations, right? So taking one and moving till the end as much as possible until we encounter a one or a end of the string. That is one operation. So for every streak, I'll do that. So this will be the number of streak that I have at this point. So you get the intuition that we need to keep track of the streak, right? And for each streak, when it ends and another streak begins, the previous streak will still contribute it. So uh, the next streak is going to be bigger than the previous streak, if you understand, right? Let me take this example. All right, something like 1 0 1 0 1 1 1 0 1 0, right? So from here I will start. I use this. By the way, why do we start from here? We start from here because if we start from here, then if you try it, you will still see that you will miss some scenarios, and we want the maximum number of operations that we can have. That's why we start from here. So 1, this will become 0 0 1 1. By I'll take this 1 and I'll combine it with the next group of ones, and my operation will become 1 because my current streak was 1. 1, this will be 0 1 1 1. Uh, I'll just copy this and just change it, otherwise I'll miss something. This will become 0, and this will become 1, isn't it? Now my streak is 1 2 3 4 5 5. So my previous streak was 1, my current streak is 5, and I have a 0. So in that case, if this was an end of the string, then I will do nothing. But since I have a streak and I have a 0, I can do 5 more operations with it. And my eventual answer will be this. Now I have another 0. I have 6 in my streak now. So my next operation will give me this. Right? So the first operation was 1, the second was 5, so 6 total. And now the last one was 6. So 1 plus 5 plus 6. This will be my answer. And that's how we are going to solve this. This is close. So we have something called streak, which we need to keep track. I'll have something called current streak, which will also need to keep track. My first initial value will be 1. Why 1? Because we will see that we have, we'll always have 1 rate in our initial streak. My current streak will also be initially 1. My answer will be 0. And I'll start like this. Since I'll be checking the next string, right, so I'll remove 1 before that, and I will continue. I'll check if s of I is equal to 0 and s of I is equal to 1. So what all things can happen, what all different encounters I will have, either 0 0 or 1 1 or 1 0 or 0 0. In this scenario, I don't need to do anything, do nothing. So I don't even have I will not have a check like this for 0 0. Here I will do something, that is increase my streak. Here I will, I'll here initialize the streak as 1. Actually, so sorry, this is 0 1 by the way. Here I will give my streak, whatever my current streak is, I will add it to whatever streak I have, I'll add it to current streak. Okay, and initialize streak back to 1. Since I have encountered a 0, so I'll initialize my streak back to 1. And here I have encountered a 1, so that means whatever previous operations will stop here, right? So I will add current streak to answer. So these 4 things we'll do. So 0 0 I don't need, 1 1 I need it. This will be I plus 1 by the way. And here I will increase my streak Similarly, I'll have check for the others. This is 1 0, this is 0 1. Here I will give my streak to add my streak to current streak and change my streak back to 1, and here I will add my answer, build my answer, and that's it. We end the loop. By the end, we again need to do this. This. Since we have encountered a end or a 1, then we have to get the answer, right? I'll have to build the answer. So I will check if the s dot back is equal to uh, a 0. If the end was a 0 as well, in that case we can take the ones and push it again back, but that won't happen since I'm not doing that and I'm not reaching the last element itself. That's why we have to take care of this here, and I will, whatever the current streak I have right now, I will add that to my answer and return answer. So the time complexity will be O of n and space will be O of 1. Let's see if this works or if there is any silly mistake. Answer then, sorry, I think here is a mistake. Since this will be a character, I have to be. So here, the current streak should not be 1, isn't it? The current streak should be 0. That's where the mistake was. Let's see if this works now. It does. Time and space will be linear and constant space, I guess. Here, this is a beautiful problem. We are given nums and target. So we can do what operation? In single operation, we can select a subarray and increase all the elements inside it by 1 or decrease it by 1. That's the other operation that you can do, and that will be counted as one single operation if we select, and every increment will be one operation and decrement will be one operation. So the naive approach that we see right away is we can create a diff array, isn't it? Here 3 5 1 2 4 6 2 4 will be my diff array. Will be my two arrays, and the diff will be 3 minus 4, 4 minus 3, that is 1. I need to increment this, I need to increment this, I need to increment this, I need to increment this by 2. So this is the naive approach, and we uh, basically create a window size, and suppose we can have also negative differences, right? For example, in this one, or let me take another example or something like, I'll straight away create a difference array which is of some sort like this: -3 0 2 5, and again a -6. Here this is a difference array, alright, and we need to make this nums go to target using this difference array. So this, our naive approach, what it will be is we create a window size for the negative and the positives. So I'll have three windows: -1, -3 will be one window, 2 5 will be another window, -6 will be another window, and I'll do something of the sort. I'll decrement this window by thrice. I'll do just one operation in the two elements, and then two operations on this. This will be 3 plus. At this point, I will have two operations run on both, and three operations run on just 5. That will be again 5 and plus 6. 6 operations on this one. This is a naive approach. We'll think that in the window size, whichever is the maximum, we'll take it. That's not the case. The problem will come in scenarios some of this sort, where we have something like, I think, or probably 3 1 5 3 4 1 or something like this. This is a difference array. This is a good example, and this is one of the test case, I believe, if I'm not wrong. And this is the test case, I think, where many of us had some wrong answer right during the contest. So in this scenario, our naive approach will be just to select this and do 9 operations here, and select this and do 5 operations here, right? Since the maximum is 5. But that's not true, right? If we do some operation, we will have some breakage at some point, right? So in that case, we'll have to deal with those two different arrays differently. So that won't be considered as a single operation, that will be counted as two operations. So our naive approach fails right here. Now we see that what will we do? We'll reduce this operation. This will be after one operation. This will be somewhat like this. I won't touch positive now. I'll be doing negative first. So this took one operation, and I have minus 8 left. So I'll do 8 more operations and get 3, 1, 5, 3, 4, 1. Now I'll deal with the positives. Okay. So 0, 0, 0, 3. This will become 2. This will become 0. I'll have a breakage point here, right? So I have to deal with this and the remaining next subarray differently. So this will be 5, will become 4, 3 will become 2, 3, 0. So now this subarray is different, right? So we have to deal with every point. That's what we understand. We can do the further operations and get to the answer, but now we see that why our naive approach fails here. Okay, then how will we do? Just right now, like how I solved, I was trying to do it one by one, right? That's how I'll do it. For 0, I'll see that I need 0 operations. So I have something called answer, in which I have 0 operations. I'll have something called previous, which will be initially, my answer will be initially the first element value in the difference array. So this will be it. Previous, what will be previous? Previous will be def of 0. So I'll start looping from here because I've initialized with the starting value, right? And I have diff array. This is my diff array. Right now I'm here. Let's start from here. I see that I have minus 1. So I have to do one operation in that, isn't it? So I'll have something of this sort actually. Instead of just diff, I will have the number of operations, that will be absolute value of diff. Alright, so this is initially 0 since my first element is 0, and this is also 0. Okay, now I have minus 1, so I'll do uh, I will I'll see my previous element. Okay, was this a negative element? If this was a negative element, then I will see what was the operation in that, isn't it? If the operation is greater than the operation in this element, required in this element, that will be its value in that case. So I'll have something called diff of I if it's less than 0, and previous, or actually diff of I minus 1 if it's also less than 0, or the opposite scenario. Alright, if it's greater than 0 and if it's greater than 0. In that case, I'll see what was the previous operation. My previous will have some operation, isn't it? So if previous operation is greater than it's lesser than the previous, the current operation, which is the case right now. Actually, the absolute, so I'm dealing with operations, I'll use absolute here. Right now, I need to increase my answer. By what amount? I have done previous operation, and the signs of my previous and current element is equal. So I'll update previous every time I go to the next element, isn't it? So this is basically uh, absolute of diff minus 1. This is nothing but absolute of diff minus 1, I minus 1. This is what I'm doing. I don't even need this actually if I think it now. Answer plus equal to what be the, I've done previous sum operations which was lesser than the current operation. So the difference, the more number of operations that I need to do will be my difference. Absolute of diff I minus absolute of diff I minus 1. If this is not the case, in that case, I will just increase my answer by, at this point what is happening is my previous element had a different sign than my current element. So whatever I have in my diff till now, I will add it. And that's how we are going to solve this. I'll have something called vector of diff, which will be initially empty. I will, since both are equal size, I can take one of the size and iterate. I will push nums of I, or the absolute value of, no, actually not the absolute value, the target of I minus nums of I. Okay, this will give me my diff. I will have something called long answer, which will be initially diff of 0. Instead of dealing with diff of I minus 1 every time, I'll use previous, which will be int previous is equal to diff of 0 again initially. I'll traverse from one first element, I is less than nums dot size, or actually diff dot size, but these are equal sizes, but I don't need to worry about it. Now, if I just copy this itself, no need to. This should be absolute by the way, since I'm dealing with operations. If this is the case, in that case, I'll check if absolute of or probably previous. What is the previous operation that I required? If it's smaller than the current number of iterations that are required for this element, which is absolute of diff of I. In that case, I increase my answer by uh, absolute of diff of I minus previous, or I will increase my answer by diff of I. My previous will need to be updated again and again. This will be diff of I, and this will be my answer. The time complexity will be O of n, space will be O of n again, and there's some mistake, and otherwise I'll increase my answer by difference, but there will be absolute value again since I'm dealing with operations. So this should work now. It does. Space complexity will be O of n and time complexity will be O of n, and oh, great. So this is failing here. Alright, so I think this is the problem. This should be absolute differences. Again, we are dealing with operations. Should work now. Yeah. So these were the 4 problems. And thanks, guys.